Let's start with a brief overview of electric resistance and resistors. Electric resistance, a cornerstone in electrical circuits, has a fascinating historical journey intertwined with the evolution of electricity. In the 18th century, pioneers like Benjamin Franklin and Luigi Galvani made initial observations in the exploration of electrical phenomena. However, it was not until the 19th century that German physicist George Simon Ohm made a groundbreaking contribution. Ohm formulated Ohm's law in the 1820s, a mathematical expression that fundamentally defined the relationship between voltage, current, and resistance, laying the groundwork for our understanding of resistance in circuits. As the 20th century unfolded, the need for components to manage and control current became evident. This era marked the emergence of the term resistor to describe devices especially designed to introduce control resistance into a circuit. Advancements in material science in the mid-20th century allowed for the development of resistor with varying properties, utilizing materials like carbon composites and metal films. The integration of resistors in electronics became a focal point in the late 20th century, where they played a crucial role in a variety of devices, from radio to complex computer circuits. The modern era in the 21st century witnessed a shift toward miniaturization. Surface mount technology enabled the development of a smaller yet more efficient resistance seamlessly integrated into compact electronic devices. This historical journey underscored the continuous refinement and innovation in the field of electrical engineering, showcasing the integral role of electric resistance in shaping our technological landscape. After historical overview, now let's understand what electric resistance or resistor exactly is. Electric resistance refers to the property of a material that opposes the flow of electric current through it. It is a fundamental concept in the study of electricity and is quantified by a unit called the ohm. When electric current encounters resistance, it experiences a reduction in flow, resulting in the conversion of electrical energy into heat. Resistors are components especially designed to introduce control resistance into an electrical circuit. They are essential for managing the flow of electric current, regulating voltage, and protecting sensitive components from excessive currents. Resistors come in various types, shapes, and size, each tailored for specific applications. Common materials used in resistors include carbon composites, metal films, and wire-wound materials. In practical terms, imagine resistors as traffic regulators for electric currents, controlling and directing the flow to ensure that devices operate within safe and desired parameters. Whether in your everyday electronic gadgets or complex industrial machinery, resistors play a pivotal role in maintaining the stability and functionality of the electrical circuits. So, till now, we have a better understanding of electric resistance and resistors. Now it's time to discuss some of the daily life applications. Electric resistance and resistors in our daily life can be found in lighting system. Resistors play a vital role in controlling the brightness of lighting system, including incandescent bulbs and LED lights. By adjusting the resistance, they help achieve the desired illumination level while preventing excessive current flow. Electronic devices. Nearly every electronic device contains resistors. They are used to limit current, divide voltage, and protect sensitive components. Resistors contribute to the proper functioning of devices such as smartphones, computers, and televisions. Heating elements. Electric resistance is harnessed for generating heat in appliances like electric stove, water heaters, and toasters. The resistance of the heating element determines how much heat is produced. In the end of the episode, Let's take some of the most frequently asked questions around electric resistance and resistors and answer them. So our first question is, how is electric resistance measured? Electric resistance is measured in ohm, named after German physicist George Simon Ohm. Instruments like ohm meter are commonly used to measure resistance in a circuit. Second question is, why do we need resistors in electronic circuits? Resistors are crucial for controlling the flow of electric current, regulating voltage levels, and protecting components from excessive currents. They help ensure that electronic devices operate within safe and optimal conditions. Question 3. What happens if a resistor fails? A failed resistor might either increase or decrease in resistance, affecting the performance of the circuit. In some cases, a burnt smell or discoloration may indicate resistor failure. As we conclude our exploration of electric resistance and resistors, we have journeyed through their historical roots, grasped their definitions, and addressed common questions to unveil their practical applications in our daily lives. Electric resistance is not just a scientific concept, it's a crucial element shaping the way electricity interacts with the world around us. Whether you are a curious mind or a student delving into the nuances of physics, understanding electrical resistance opens a door to appreciating the intricacies of electrical systems.